I got this 60 MHz arbitrary function generator from Banggood at no cost to try out. It's a FeelTech or FeelTech FY6900, and it can put out the usual waveforms, including some custom user-downloaded ones, and it has options like 2 independent outputs, sweep, modulation, a counter and frequency meter, and there's BNC jacks for external triggering or syncing multiple units, and it can be externally controlled with a VCO input, a PC application, or just serial commands over the USB UART. EEV blog has multiple thread discussions covering the history and evolution of this unit from previous models, and includes links to teardowns and upgrades, so I'll link that for anyone curious. The PC app is Windows-based, and I'm not on Windows, so I can't get mine working over serial, but it allows control of the unit's functions, and using data points or hand-drawn waveforms within the app, custom waveforms can be downloaded into a chosen arbitrary channel and stored in the unit. All the BNC grounds are connected to Earth, so that may need to be taken into consideration depending on what your full test setup requirement is, if you need that to be isolated or not. Let's flip through some of the built-in waveforms while looking at some of the specs. Given the price point, this unit would be targeted at the casual hobbyist user who needs more than just a homemade square wave oscillator, and it has a lot of features and functionality, so it's a good unit to try out and see what features you'd really need or want in a signal generator if you're not sure. If you already know what you need and you want something you can count on with polished firmware, you'd probably be looking at a higher tier of test equipment anyway. My own intended use of the unit is to be able to generate some basic waveforms and control them over USB for some automated testing and use it as a backup unit. Looking at the specs, in summary, the outputs go up to 24 volts peak-to-peak for all waveforms, where the upper and lower limits are bound by plus or minus 12 volts, and it can do 24 volts up to 20 megahertz. Then it drops to 5 volts peak-to-peak for the rest of the way up to 60 megahertz. This is one of the things I'll be looking at to confirm the spec because there's been known to be typos in the documented specs as the models evolved and specs changed over the years. The unit is FPGA based. It has 2 outputs plus a hardware frequency meter and counter that all run simultaneously as independent units. There are some firmware glitches I've noticed, but it is supposed to be upgradable via the PC app. So let's check out some of the features and you can decide if it seems right for your needs. To start out, I'm using a 10x probe with these BNC to alligator clips that came with the unit just to test the higher voltage outputs. And later I'll switch to a 50 ohm terminated BNC connection using the BNC cable that came with the unit. So this way there's not too much power dissipation at high voltage on this terminator. When I powered up, this showed me firmware 1.3.1. One of the first things I did is go to the system menu, config, and turn off the buzzer. I don't really care for that. And I also made sure that on boot, channel 1 and channel 2 are off because it defaulted to turn them both on when you power up, and I'd rather have control over that. In case I have a short on the cable, it's not set up properly, I don't want to drive an input that I'm testing until it's ready, so I just set those things up the way I want. And this standby switch here, I don't really know what it's doing in standby mode, so I just use the main power at the back. So the first thing I'm going to check while I have this higher impedance probe connected, where I'm not really looking for the signal integrity going up at high frequencies, I just want to check the maximum voltage I can get at certain frequencies and for different waveforms. For now, I'm starting with a sine wave at 10 kilohertz. Currently it's set at 5 volts peak to peak. So here I have 5 volts peak to peak, and I'm also measuring just the peak, so I got 2.5. And the frequency as well as up here. So if I just zoom in on this waveform while I'm here, just to see how it looks, I want to change the amplitude. So I notice I hear a relay click when I go above 5 volts because it's switching to a different output amplifier circuit. So the characteristics of the waveform may change. While I'm doing that, I turned this down to 1 volt. Now if I want to change so that I'm going down by 0.1, I just use this to move the cursor over, and now the knob will change right here. So when I get down to 0.5 volts, there's another click because we're changing the output again. So those are some levels to keep in mind. Back to 5 volts. I will increase this until I get to the maximum 24 volts peak to peak maximum. So just zooming in again at 24 volt peak to peak. Now what I want to do is change the frequency. I will put it up to 100 kilohertz. I'll put that to 0, move the cursor over to 100 kilohertz. Just increase it 100K at a time up to 1 meg. So now there's the waveform, still giving me the 24 volt peak to peak. Of course, it's looking a little fuzzier. Now I'll bring the cursor over to the megahertz and increase 10 megahertz. Now we're starting to lose our shape, and trying to drive such a high level output at a higher frequency. Again, I'm only looking at right now how much voltage I can get out rather than the shape of the wave. I keep increasing the frequency, now being at 20 megahertz of course. Beyond here, I would start exceeding the scope's usable bandwidth, 1/5 of the 100 megahertz. But here, when I switch to 21 megahertz, the amplitude drops to only being able to do 5 volts peak to peak. So we can do a sine wave up to 24 volts peak to peak, then beyond 20 megahertz, we're at 5 volts. So if I go all the way up to 60 megahertz, I can still do 5 volts output. Whether I can measure it on this instrument accurately is another story. But I do have 60 megahertz, a little bit wobbly. Now it's set for a square wave. Of course, we have all these spikes with our cabling set up. 100 kilohertz, I'm on 5 volts peak to peak. How high will it let me set this? I can also go 24 volts peak to peak. Change the frequency, starting at 1 megahertz. At 5 megahertz, 24 volts peak to peak, it's starting to look really strange and starting to turn into a sine wave. But I get the same thing. I can go up to 20 megahertz before it drops to 5 volts. And if I keep going in frequency, I can get 5 volts peak to peak all the way up to 60 megahertz. But of course, with this scope, not being able to represent the waveform, it looks like a sine wave. Triangle wave, 1 megahertz to start, 24 volts peak to peak, and 20 megahertz. As soon as I get to 21 megahertz, it drops to 5, and I can do 5 volts all the way up to 60 megahertz. Ramp waveform, same thing. When it gets past 20 megahertz, drops to 5 volts, and 60 megahertz, 5 volts. And this P-pull wave only goes up to 12 volts amplitude, and it's giving me just this positive rectified looking output. So as I change the frequency, it goes down to a max 2.5 out after 20 megahertz. With the arbitrary user downloadable waveforms, Arb1 by default on mine has a sine wave, so I can set arbitrary output to 24 volts. Again, above 20 megahertz drops to 5 volt amplitude all the way to 60 megahertz. So I put on a rectangle wave and I can change duty cycle. So on the scope I've turned on all the measurements, so I have plus and minus duty cycle both 50%. Now I can change this 55%, so it's 55 down here and up here. I can go up to 99% duty and it measures as such. And then I move the cursor over. It may be hard for me to measure on the scope, but I can change it 0.1. I can go 99.9. I can trigger on that. So I'll go back down 99.1, 99.0, 98.4. So we get to go in there and fine tune the duty. And if I go all the way to the bottom end, now I'm at 0.1% duty. 0.2 and so on, 0.5% duty, 1% duty, so I can control it that fine. I can even go more fine, so now I'm at 0.01, I don't know how accurate it would be, but I can really go in there and change the numbers on a small interval. Now I put a second 10 times probe on, and I have two identical sine waves set up, and I can adjust the phase. So I take channel 1, and right now it's 30 degrees. If I go 90 degrees, there it is. I can go 180. That looks about right. And all the way up, I can bring it up to 359.999, not quite a full 360. And setting it back to 0. Likewise, I can't go negative phase shift. So what I would have to do is go to channel 2 and go to the phase there and increase channel 2, say 30 degrees. So in that sense, channel 1 went negative 30 degrees. Right now I have it set for a rectangle wave with a duty cycle 25%, 1 kilohertz, and it's 2.5 volts peak to peak. So I'm going to plug this into the counter input, go into counter mode, and it's counting 1 kilohertz, and the duty being 25%. So if I go back to the waveform, change it to 100 kilohertz, go back to counter, now it's 100 kilohertz, and so on. And the spec says it can count up to 100 megahertz, which this unit itself can't put out, but I'll go all the way up to 60 megahertz. And I'll even change the duty. Now it's 85%. Go to the counter. 20. And there's one software glitch that I've noticed before. It's showing 20 megahertz, which is a third of what I set it for. In the past, I got this 1/5 of the frequency I was set for. So let me try putting the duty to 50%. Okay, now it got 60 megahertz, 50% duty, although it's going up to 75. It's all over the place. But that was just something I wanted to point out. So now I'm putting the 50 ohm termination on and putting this back on the scope. I'll try to get this cable out of the way without knocking everything over. Now I'm in the modulation menu and there's a burst mode. I have it set for manual and the number of pulses 5. So it uses channel 1. Right now I have it at a sine wave 10 kilohertz and amplitude 2.5 volts. But with this 50 ohm terminated cable, the amplitude is going to be half. So it's only going to be 1.25 volts peak to peak. So being on manual trigger, I press OK, and it sends out those 5 pulses in a burst. 1, 2, 3, 4, 5, and 10 kilohertz, and about 1.25 volts peak to peak. So if I change the parameter, which is the number of pulses, it can do a lot. Let me put it to 15, and that should be 15 sine wave cycles. For these other modulation modes, I don't really use any of these features, so I'm not even sure how to configure them or demonstrate them. I don't know what I'm doing. Otherwise, maybe somebody else has demonstrated this more skillfully. So I'm going to go over to the sweep mode, and I'm going to choose the channel 1 frequency. Let's start at 0.5 hertz and go up to 100 hertz in 5 seconds linearly. Well, it's definitely going up to a maximum of, looks like, 100 hertz. There is 0.5 hertz up to 5 hertz over 15 seconds. So if I change this to amplitude from 0.1 volts up to 5 volts in 15 seconds. And here's the sine wave sweeping up in amplitude. So depending on what we need to do, we can also sweep the duty cycle or an offset level. So there's options. So let's look at the offset. I can move this up or down. So I can set this plus or minus 12 volts. So with this on 50 ohm termination, if I go up to 5 volts peak to peak, and then I switch over just above 5 and we hear the click, that's where a different output stage kicks in. So at least at 5 volts, I just see a very slight amplitude reduction actually when I try to go a little higher as it switches over to a different circuit. And going down in amplitude, when I go down to 0.5, it clicks again into a different output stage and has a bit of a jump there. And then it just continues on. Just to be aware of it, that's there. So I'm going to go back to about 2.5 volts peak to peak. So there's a 10 kilohertz sine wave, and it's peak to peak around 1.25 volts with our 50 ohm termination. So if we just zoom in on that, that's how it looks. If we switch over to the square wave, that's how that one looks. And with the capabilities of this scope at least, just at 10 kilohertz, we got a rise time around 6 nanoseconds showing up here. Back to sine wave. Well, how low can we get this voltage? I'm set for 5 millivolts peak to peak, and yeah, if I'm measuring 2.5 millivolts peak to peak with 50 ohm termination, okay, so let's say I want 50 millivolts. There's my approximate 50 millivolt peak to peak sine wave, 10 kilohertz. So I'm going to bring this to 1 megahertz. There's our sine wave. If we zoom in on it, maybe freeze frame, there's how I can pick it up on this scope. If I go over to a square wave, that's how that looks. And if I try to get a rise time on that, this scope again is picking up around 6 nanoseconds. Back to a sine wave, I'll go up to 10 megahertz. Freeze that. So yeah, now it's starting to get a little weirder looking, but again, how much of that is attributed to the actual scope capabilities and even the probing. This is the cable that came with it. I don't know how good that is. So if we zoom in, there's that. Go look at a square wave. 6 nanosecond rise time. Back to sine wave. 20 megahertz. And at this point, beyond here, of course, that's pretty much the reasonable bandwidth limit of the scope, so anything to do with amplitude or even wave shape. I'm just looking for frequency and any obvious weird artifacts. Square wave, starting to get a little bit wobbly on the top and bottom. Still seeing that same sort of rise time, 6 to 8 nanoseconds. That's starting to mean less and less with the shape of the wave changing now just due to the scope. And if I just continue on a bit, there's a triangle at 20 megahertz. Of course, it's starting to filter into a sine wave, and just going all the way to 60 megahertz now on a sine wave. There it is. And of course, its amplitude is reduced just from the fact that it's being bandwidth limited here, but we got 60 megahertz. Square wave, it also looks like a sine, and all the other waves probably do as well. There's our triangle, and just back to sine wave. So yeah, I would need a higher bandwidth scope to actually be able to see if this can put out a clean, proper waveform at 60 megahertz while maintaining amplitude and such, but I don't think I'll need to go that high. If I put the frequency back around 10, if by chance I'm doing something where I do need 10 megahertz or even 20, at least I know I can get various wave shapes and put those to use. Looking at the document for the protocol of the serial interface with USB plugged in, we look up these commands and basically press enter. So for example, to turn on the channel 1 output, WMN1 and enter. And whatever way it was configured, now the output is turned on. And it's a 100 kilohertz sine wave at 2.5 volts peak to peak. So if I want to change the frequency, I enter in the microhertz value that I want. So for example, this is 2.3 megahertz. So I press enter, and we've switched over to a 2.3 megahertz frequency. I'll put that back to a manageable 100 kilohertz. And we can change the amplitude, WMA 2.5. I messed up. It's already 2.5, so WMA, say 4.5 volts, peak to peak. And we've updated the voltage and it's changed. So I'll put it back, 2.5. And with the command WMW1, we change the waveform to a square wave. And if I want to go to channel 2, it's WFN1 to turn channel 2 on. So channel 2 is set for a sine wave, 100 kilohertz, 5 volts, peak to peak. So we have 2 volts a division versus the 1 volt per division here, so they look the same, but they're different voltages. WFF, I'm changing the frequency of the second channel to 10 kilohertz. So there's that. Using USB control to turn the channels on and off and switch what they're doing could come in very handy for some automation. For me, this works fine, and every individual will have to figure out what works for them. For the cost and for what it does and how it seems to be performing for me, this would never be my main unit, but if I need a spare square wave, sine wave or something as a test thing, or if I need to control this from a computer for some automated testing or something, that's when I would really have a good use for something like this. Thanks to Banggood for sending me this to evaluate. Hopefully it was helpful or insightful in some way. I'll see you on the next video.